Good morning. Buenos días. Imagine you join a new company and you get your first piece of hands-on work. So you're very excited to look at this code base and discover what is there for you to learn and how you can contribute to it. You're a software engineer. You have a few years of experience, so you're expecting to be familiar with it fairly quickly. But your first thought is, this code makes no sense. And you secretly start blaming whoever worked on this before you. Because you're thinking, where are the tests? Where is the documentation? You go into the Git log, and you start going through the history, and that really doesn't give you any information. It's just update, update, new feature, new feature. And you're wondering, why have they decided to implement this thing in this way? And you're kind of wondering to yourself, how can I start diving gradually into understanding this? How can I even make any changes with confidence? And also, you start thinking, am I going to be fired from this job? Has this happened to you? Raise of hands? Yeah? Because it's definitely happened to me more than once. But what if you could imagine a future where you have a clear framework in your head for how to proceed into this unknown? You know where to start, you know who to talk to, and you also know what questions to guide you along the way. In this future you have the self-belief that it's all going to work out in the end. The journey is going to be worth it, and it's also going to help you level up as an engineer. So my big idea is that maintaining software is very different from working in greenfield. Even software systems that are not decades old, they have a lot of technical debt. And sometimes it happens in companies we wouldn't expect to. People think that technical debt is big old banks, hospitals, like places that started their technical adoption very early on. But actually, these days, I see smaller companies, high-growth companies, accruing a lot of technical debt because, well, sometimes the focus is not on the health of the code base, but on getting product-market fit, on being profitable, on delivering value to customers quicker. I'm not here to teach you how to do your job. I know you can already do it far better than I could ever do. But I want to share a different perspective that helps you see things in a different light or see them in the way that someone else might. Good morning, buenos días. My name is Blanca. I'm a principal engineer. I'm also a transformational coach. I founded my own company to help engineers on this journey. So I have been working on software systems for almost 2 decades. And many of the roles I was hired for were to modernize software systems or even rewrite them altogether. I have seen successful and failed technical debt initiatives. So I'm here to show you what I have learned. Because legacy code has been part of every job. I've either worked to address it, but I've also created it myself. When I think about it, I realize I love this part of the job. I've always loved understanding the history of things. What were people thinking? What were the constraints they were working under? But I also love understanding why things fail. So when people say to me, oh, this is legacy, Blanca, just, you're not really going to understand it, just stay away from it. I say to people, where do you say this is? I'm just asking for a friend. And I quietly go towards it. But it turns out I'm not the only one excited about this. Many years ago, I searched on Twitter to try to find some solace, some people maybe that thought like me. And I found Monica's tweet where she said, I wish we had a legacy conference. I thought, oh, wow, this is even bigger than I thought. And I'm thinking, is there anyone here who also shares my love of legacy? Well, there's a few. Amazing. Welcome. Because I think legacy provides an opportunity for learning far beyond what we'd imagine. When I started as a junior engineer, I was led to believe that working in new projects, what we call greenfield, was the thing to aspire to. You want to craft things, you want to develop that idea. But then as I moved jobs and I saw my friends moving jobs, I was looking around thinking, what am I doing wrong? Because I keep going into projects that they're usually maybe in a bit of a mess, and I just have to try to leave them better than they were. And then, as my career progressed, I realized, actually, this is almost like the normal for all of us. But if we started with the same beliefs that I had, then we're very badly equipped for what's to come. But also, as junior engineers, we need to learn these skills. And I think this, definitely I wasn't taught this, not in university, not, at the very beginning. So I wasn't maybe the most pleasant engineer to work around because I was just complaining. And sometimes I was complaining about the work of the person sitting next to me. So in today's talk, we're going to be going through the following: the introduction, and then we're going to be going to 3 skills to learn together, and then we'll just wrap up and have some questions. So we just done the intro, and the first thing I want to share with you is cultivate a learning mindset. This is the first skill that I realize is very key, is adjusting the way we think. And why do I say this? Because the way we look at things really changes the ideas and the questions that we have about it. And this came about from me coming across a book called Learned Optimism. And yeah, I know it sounds like toxic positivity, but hear me out. This is about staying observant instead of jumping to criticize. Asking open questions and thinking, well, this module is just so ugly, all this spaghetti code. What happened here over time? Trying to think and put ourselves in the shoes of the people that work on the systems before us. And it also helps us understand assumptions and constraints before coming up with a solution. So this is about understanding what is the problem that I'm working with. And I wondered, well, analytical thinking is what we do most in our jobs. We're problem solving. We're diving into code bases. We go into very deep work daily. And I thought, why did I find it so hard to then shift the way that I was thinking? And I realized that because analytical thinking is what we do most in our jobs, we don't spend enough time building other skills. Empathy and emotional intelligence are key to cultivate this learning mindset. And also, as senior staff engineers, architects, also engineering managers, we are the ones who influence those around us. We are the ones who almost set the mood for our teams. And I can definitely tell you that as a junior engineer, my mind started shifting when I worked in a team that was dealing with a Java product that was more than 10 years old. This Java product was a Java web app, but it was written before even Spring came about, the Spring framework. So it had kind of like its own crafted dependency injection system that I just thought, oh my God, how even grasp this? But the engineers in the team, they showed me how to start kind of almost breaking the layers, breaking it down. There was a way to debug locally, so I could just make changes and then go through the code. There were not many tests, but there were conversations how different tasks that we were taking on, new modules were being added. We're trying to do things in a better way. So I think they were an amazing influence for me because they really led the way for a better engineer version of me. And then later on in my career, I paid that forward with other people in my team, and I showed them, hey, I know this is messy, but we can get through this together. And if you want to pair with me, you can just learn, and we can ask the questions. So there's a quote that I love from Ian Bogost that says, operating under constraints is the key to creativity and fun. Maybe these are not the constraints you were thinking about, but when we can take a step back and understand that, hey, at the end of the day, this is the package that comes, and we can maybe think, what if I play this like a game? I have to make sense of this. I have to change it. How can I make it better? How can I win this game? Then our minds start getting into that learning mindset. It's almost like we're really lifting ourselves through this, because negative thoughts are not helpful for ourselves or for others. But why does technical depth matter beyond this code quality? Okay, because I hear a lot of engineers frustrated, but also when I speak to product managers, to business people, everyone is frustrated. You mention technical depth, and people just get angry and don't listen to each other. Well, it matters for productivity, so this, getting our job done in an effective way. Happiness it is important for the learning mindset aspect, actually. The happier we are, then we show up to work with a more pragmatic way of thinking. We're better problem solvers. But also, the way we code, the way we update things. If we can make successful changes, the reliability of our systems is improved. Because back in this project, this Java web app that I worked on, I could only test locally, but that didn't mean that everything was great. We only released twice a year back then. It was 15 years ago, but it was twice a year, sometimes once a year. We had testing phases of more than a month, where we had some servers that all the tests, actually, they were kind of end-to-end tests being run sequentially. But it took a month. It was very expensive to test that way. So the reliability of our system wasn't great, because a lot of bugs came out from these testing phases, and the cycle of fixing them was very, very slow. And you're wondering, well, why do I have to do something about tech debt other than, well, reliability? Yeah, maybe it's important, maybe not. Happiness, we're here to work, let alone be happy. Well, if tech debt builds over time, I've learned a new term that is called the software event horizon. So as tech debt increases exponentially, your system becomes harder to maintain. This means that whenever you push a new change or a new feature, it is more likely to fail. And the accumulated failures over time can lead to the system actually stop working. And I've seen this actually becoming true, because as I embraced the cloud and I deployed my systems on the cloud, maybe I wasn't making that many changes to my components, but the underlying platform was changing. Our cloud providers, they change. They change the hardware. Some of the libraries get upgraded, and that impacts on our applications running on them. So yes, I have definitely felt it coming. But also, I advocate that doing nothing is not an option. I see a lot of fear in the teams that I work with, in diving into something that is uncertain, that is unknown, that people might judge us as professionals. And it's almost better to just kind of leave that closet closed and not open it and see how many skeletons are there. But also, there's a story of a team that I joined much later on in my career. They had inherited a big data pipeline from a previous team. And there was no test environment for it when I joined. There was a lot of infrastructure, and there was a MapReduce job running as some of the steps of that. We had a lot of failures. Okay, it was ingesting terabytes of data overnight, and a lot of days I would arrive to the office, things had blown up. And people would get really upset because this data was very critical to that business. There were only 2 people left, not from the original team, but from the team that came after that. A lot of developers had quit, and these 2 people were just trying their best. They had automated some scripts so that they could automate some of the deployment, because the deployment was very manual. And it was impossible to know sometimes what had happened, but also, because we had so many incidents, we had to guess sometimes what the problem was, and we could only test it in production. So you can imagine that going really wrong. And I have to say, I was frustrated at the start, and I just thought, how are we going to make it through this? But then these 2 engineers led me the way to think, how can we learn about this together? There will be a time that this will change. I just don't know when. It's out of my control. So what I did is, first I paired with these 2 engineers to learn what is the work they've been doing so far. And then I suggested, let's try and crack this test environment. And they were just like, oh, I don't think so. And I worked on that for many weeks until we managed to have a test environment. And that kind of started shifting the needle. So I could see how small steps, building over time and sustaining the effort, could really change things. The second skill that I wanted to share with you was creating a map of the software system. And this is using these different skills. So anyone here familiar with systems thinking? Yeah. So for those who aren't, systems thinking is a way of taking a step back, in this case from the code base. You take a step back and you start to see things around it as well. So it's about the architecture design, the documents, the different things around it. And it's about creating a map that will guide us. Okay? You don't have to create a full map of the system as you're working on this feature, but you can start to kind of almost draw yourself a few diagrams, ask a few questions, and this helps you understand what is the system meant to do. So I advocate going in layers. I know as engineers, we're very comfortable with the code, so we immediately jump to the code. And they were just like, oh, this thing is just, I cannot touch it. Start to see, is there any architecture diagrams? What do people have in their notebooks? Because I find that, as engineers, we keep our notebook with all this knowledge, but sometimes that is not really shared. So I ask people, what do you have in your notebook? What documentation is there? And then after you've kind of looked at these things around your system, you can maybe start going into the system being, are there any modules there that are smaller? Maybe that makes more sense of it. Where is my feature? Is my feature maybe isolated from the system? It helps me kind of just remove some context to grasp it. And I remember many years ago, I joined also a new company that I just couldn't make sense of things. And people kept going into the code base, and that for me just didn't make a lot of sense. And the more I spoke to engineers in my team, it actually became clear that a lot of people also didn't have that clarity. So sometimes starting to ask, as you are a new joiner, it's actually a perfect time to just ask any question. People will give you a lot of grace. And also, as a new joiner, you can contribute small documents that help everyone come together in the understanding. I'm going to go back to fun. Because when we think about something that is fun, we're just thinking maybe that we're on the sofa or we're cozy in a place that we like, having a drink, playing a video game, doing something creative, a creative hobby of any sort. But actually fun happens when we tackle a familiar thing in a different way, because that's about being creative. When I discuss systems thinking, this is also about speaking to people. I mentioned about speaking about your teammates. But then in companies, we have more people who know about our software. Sometimes I found that business analysts, if they're present, test engineers, product managers, and even salespeople, they know far better what things are meant to be doing, and they have the context in their heads. Oh yeah, this feature was shipped very early with a few crutches because this customer really needed it for this thing. And when you understand that, you're like, oh yeah, it makes sense. It helped the company, gain a customer, so this is great. But it also helps you, what are the constraints? And you can document those constraints, and that is key for then moving forward. I'd say, please try to speak to people who are not engineers. This doesn't come naturally, as we are used to speaking the same language, but it really builds relationships as well, as people see that you're curious to learn. You want to understand, you want to create those bridges. And the last thing to look at, in software systems, they always tend to be connected. Maybe this is my experience, that I've worked in a lot of backend systems. They tend to be connected to other things. So if you look at those edges around it, there tend to be test contracts, API contracts, even data contracts that say, what are the expectations of the people who are in this system? And that also can help you kind of have a way in to start understanding what it's doing. For example, going back to this batch process that I mentioned earlier, this was written in a very, very old version of Apache Spark. And also this infrastructure, it was Amazon infrastructure as code, which is, if you've seen it, back then it was JSON, it was just not friendly to understand. So we started looking at what are the downstream use cases for this data. This data was being dumped in a data warehouse, and it was also being dumped in a data lake, and there were a ton of downstream consumers. There were a lot of critical business dashboards, and we started to have a look at those dashboards to see what are the fields that people expect to use, where is the shape, and it would also help us then when there was a failure to understand if this is a particular column of the database the failure has been, this is what the user is expecting. So it helped us to kind of create hypotheses for what sort of thing might have broken the system. And the last skill I would share with you is learn how to prevent and even predict possible pitfalls when you're creating new systems or when you're kind of updating new systems. And a personal story about all these failed systems at the time. Most of them got a lot better, because one of the practices I've seen those teams doing is documenting incident reviews. So as things fail and you get frustrated, it's an opportunity to learn. If you learn and also document what was the failure, you're starting to create breadcrumbs for your future self and your future team. And it really changes when maybe things down the road are read by someone else. It creates that kind of shared code base. And I don't know about you, but I forget very quickly why I have decided on something. So I started documenting these things almost for me, because people started to come and ask me things. And the only thing I could come up with was, I am sorry. I'm sorry this happened. I'm sorry I did this. I don't know what I was thinking that day. And that's not really sufficient, is it? It doesn't really build relationships with your teammates. So documenting these things reminded me, what was the situation? And when people even ask me, I could say, oh yeah, I wrote this down because this thing, this thing that says here, this thing happened. And they were like, oh yeah, that makes sense. And it would kind of remove the judgment, creating that log. So there was this big data pipeline, actually. One of those failures that happened, it only happened intermittently. And I don't know about you, but those are the things that upset me the most. Because I said I love failure, but I think it's because I love fixing failures. You get that rush of energy, you feel great. But this thing, it was just like once a week, once every 2 weeks. first, we spoke with our product managers, we spoke with our stakeholders on our team, and they were like, well, you might just leave it because this system is going to be decommissioned. We don't really know when. But I was very upset because it just kept happening. And every time we had this failure in this data pipeline, actually, because it failed in a big bang, it meant there was no data for an entire day. So this meant that in the business dashboards that were being used to make decisions, there was a gap for an entire day. And that's a lot. So I suggested doing an experiment to my team and my product manager. I said to them, let's hypothesize together what might be failing, and then see whether someone wants to spend time just trying to prove it. So we hypothesized together ideas. We thought, well, if it's intermittent, it's definitely something in the data. That's what it looks like. And we kind of thought, well, for every record, there were 300 fields. I didn't know how to narrow those down. Reading the code really didn't tell me where it might be. We suspected it might be something with one of the fields not being properly escaped. But when we looked at the code, that was being dealt with. That use case was there. But I still thought there's something there. And turns out that really no one was very keen into actually testing this because it was very manual. I had to create some bash scripts to divide and conquer this data set and start doing small tests. So deployed smaller clusters, put through a small data set. If it failed, then the candidate was there. If not, that data was okay. And luckily, I wasn't doing this on my own. We had a graduate in our team, a junior engineer, and I said to her, I know this is really not sexy, but I think we can learn something together. And she said, yeah, let's do it. And we spent 2 weeks doing this until from 1 billion records, we narrowed this down to actually 5 million. And 5 million is something you can actually play with in your laptop. So we started doing a lot of grep commands on the command line. Just trying to play with different fields and discard until we found it out. And I was like, I remember looking at her and saying, oh my God, 2 weeks, we found this. And her face changed because it was the first time she'd seen something like this. There was one field that it had been doubly escaped. I know you're thinking, 2 weeks for this. I wouldn't advocate necessarily spending that amount of time, but we documented this. And actually, a few months down the line, this system was decommissioned. Our team expanded, and all this collected data from incident reviews led to the design of a new system. I also took on a lead opportunity because I was like, well, I've troubleshot a lot. I'm actually keen on asking engineers the questions, working with my architect, and just making sure that these things that we've learned don't happen again. And it was amazing. The team took ownership. There was a lot of data, a lot of learnings from the failure, and they applied and going forward. So when we document, there's also other practices, other metrics that can help us. There are 3 frameworks, DORA, SPACE, and DevX, that have come about in the last 10 years or so. I'll go quickly into them. DORA is very much focused on the CI/CD pipeline. Then we have SPACE, that was an evolution of that, and it's more focused on the team and individual dynamics. So that's a bit better, but not quite. And then DevX came about a couple of years ago, and it's more about developer workflow, team dynamics, and it measures it's a more holistic view of your system. So DORA got really famous in 2013, 2014, because there was a startup that came about actually named DORA. They did this big test survey online, and they realized that highly productive teams, they had these metrics, and they actually kind of took care of making them better over time. But when you look at these metrics, well, they're just about deployments and about changes. Our teams don't work in isolation. So that company got acquired by Google, and the same people actually realized there were some limitations from DORA. So they came about with something called SPACE, which stands for satisfaction, performance, activity, communication, and efficiency. And this looks more about how people are interacting, about how easy it is for engineers to make a change in the system, how are they collaborating together. So this kind of tells us a bit more. But then DevX took another step back, and it looks about the whole developer experience. It has 3 dimensions. It's defined in a triangle with 3 dimensions: flow, feedback loops, and cognitive load. And this is where I could pinpoint this big data pipeline. It definitely created a huge cognitive load because it was like a big bang thing. It's really hard to put that into our heads. But also, the challenge was so big, and my skill sets wasn't really matching, so I couldn't really get into flow either. There's a lot of fine-grained metrics that comes to it, but I'm going to leave you with this because there's a ton of information. And with these metrics, you can help yourself and your team develop some practices to actually prevent that technical debt going forward. The first one, I'd say, is prioritize this type of work regularly. It's better to do in small chunks. Big bug rewrites happen now and then, but really not that often. Second, adopt those good team practices. Documents, commit log messages, write something that is useful for yourself in the future. And also, if you're making architecture changes, document the decisions. Document what will be done, but also what you decided to not do. These are very useful for the future. And lastly, be intentional about when you need to actually take on this tech debt. Sometimes there's a bigger priority. Document that. And that way, in the future, you can address it. You can even put a deadline on it and say, by this time. But at least you know that that was intentional. So we've come to the end. What are the key takeaways? I say learn these 3 skills. And that way you can live with tech debt more effectively. Cultivate a learning mindset. Create your own map of the software system. And know how to predict and measure these possible pitfalls. And lastly, I'll leave you with a quote. Motivation isn't something that you come to the office with or you just leave. It's something that you build. By understanding your desires, you want to be able to work on this system. Facing your fears. I am scared. I'm not good enough. And then designing the actions that feel good to take. Having a framework. Having questions to guide you through. And this is a quote from actually Moni, my coach. Thank you.